Hello, I'm Neil Young and I'm the Technical Manager attached to the sales team at Palintest HQ. In this section of the webinar, I'd like to run through some best practice guidelines to help you get the best possible results you can from your Palintest photometer. Now, many of our technical support conversations begin with one of our customers getting an unexpected result on their photometer. They may have a zero value for a concentration when they are convinced that there is something present. The value may have been too high or too low compared to what they expect. Or they may have received an out of range or error message on their screen. So what can you do if this happens? The first thing is not to panic. Whatever the result or message is, there is, in most cases, a simple explanation. And of course, there is always the possibility that the photometer result is the correct value. Just because you don't like the result of a test doesn't mean that the result is wrong. The most important thing to appreciate when carrying out a water test is that it doesn't start when you put the sample in the photometer and press read. That is really the final action in a multi-step process. So best practice involves care and attention right from the beginning. So starting from when the sample was taken, was the sample collection done correctly? Was the sample representative of what you were testing? For example, swimming pools are known to have a different chemical composition at the surface and at the corners. So taking a sample from these areas of a pool does not represent what is in the main body of the pool. So pool samples are usually taken from at least elbow depth and consistently from one location on the longer side. Could there have been contamination? For example, water utility technicians sometimes carry what they refer to as a dilute 1% chlorine solution in a spray bottle. 1% is in fact 10 milligrams per litre. So it is easy to see how cross-contamination from the spray could cause a high result when testing samples for chlorine that are below 1 milligram per litre. When taking more than one sample, it can sometimes be difficult to collect two samples that are the same. An effluent stream is a good example of this. Sometimes a sample sent to a lab will be treated differently to the one tested there and then on the photometer. The extra time taken to process the lab sample may have allowed the sample to change. If a sample has been stood for a while, could a sediment have settled out? Again, this is common in effluents, and the parameter being tested for, such as a heavy metal, is often in the sediment. Most tests involve preparing the sample by adding reagents, usually tablets, to a 10 ml sample tube like this. If part of a tablet is undissolved, then the colour shade in the sample tube may be correct, but the colour density will be lower because some of the indicator is still in the undissolved tablet. Alternatively, the colour reaction may not be complete because vital reactants are unavailable. Small floating particles of tablet can also affect the optical measurement. Cross-contamination is a particular risk at this stage because all the equipment, the tube, the lid, the crushing rod, etc., may have been used previously for a different type of test. Rinsing equipment multiple times with the sample being tested is often the easiest way to avoid this type of contamination. Sometimes it can be worthwhile specifically labeling tubes and crushing rods and only using them for one type of test. Touching the tablets is also a common cause of contamination. Even if it is done really quickly, it will not avoid contaminating the sample. Our photometer tests are mostly calibrated for 10 ml. If this volume is wrong, the colour indicator will be diluted or more concentrated, and this will affect and cause an error in the result. The curved surface of the sample, called the meniscus, should just be resting on the white fill line. Better still, use the 10 ml syringe included in our kits. Again, rinse it many times with sample to ensure that it is clean and free of contamination. Observe the sample as you prepare it. Most photometer tests involve developing a colour and, as Hannah explained, this colour is measured in comparison to the blank. All other optical properties of the blank and the sample need to remain identical to each other. Any staining, scratches, or fingerprints on the glass tubes used for the blank or the sample will affect the reading. Look out for cloudiness or turbidity. Sometimes something in a sample may react with the reagent, causing cloudiness. So even if the reagent color is correct, this further reduction in light transmission will affect the result. In some cases, such as with our ammonia test, we know that turbidity is caused by high salt levels in seawater. In this case, we supply a conditioning reagent to prevent this. Sometimes a sample will degas and go cloudy when taken from a tap, so both blank and sample are affected. This needs to be allowed to clear. It will do so from the bottom of the tube upwards over a few seconds, and this will also confirm that the cloudiness has been caused by gas bubbles. Bubbles can also form on the inner walls of photometer tubes, especially when the tubes are old or have seen significant use. This will affect the light reading. Remove any bubbles from tubes by capping the tube, turning it on its side and rotating it on its axis. The air gap and liquid surface will then remove bubbles from the wall. Of course, it will be critical that this cap was thoroughly rinsed before use, again to avoid contaminating the sample. And finally, there are some basic housekeeping issues which mostly speak for themselves. Firstly, reagents need to be in date. All our reagents carry best before dates, both on the outer packing and on the tablet strips and blister packaging inside. With many tests, we do high range and low range versions, and sometimes even medium range. We also supply reagents in liquid format in pre-filled tubes, so inadvertently using the wrong reagents is not unknown. Many tests have particular techniques described in the test instructions. There may be optional reagents, like I mentioned with the ammonia test. Some tests may require a waiting time. It goes without saying that following the test method is important. We are trying to help our customers reduce errors when following instructions by rewriting them in an easier to follow pictorial format. In this example, there is a do not crush instruction and a wait time. So in summary, getting the best result involves considering the whole of the test process, from sample collection to the recording of the result. At every step, think about the opportunities for contamination and be observant, especially for anything that might affect the light transmission through the tube in the photometer, because that will affect the result.